Hello boys and girls, and welcome to lesson 1-7 from page 37 of your textbooks. We're going to look at words, equations, tables, and graphs. We're being asked, the first question is to scan lesson 1-7 in your textbook. Predict two things you will learn about multiple representations of equations. So what are we going to learn about? Well, when I look at example 1, we're being asked to create a table, write an equation, and graph the order pairs. To me, those are all different ways that we can represent relationships. So, how to represent relations in a different way or in different ways is one of the things we will be learning. How to write them in equations, in the form of equations, how to write them on a table, and graphing or in order of pairs. And another thing that we're going to learn is about equations. Words, equations, tables, and graphs can be used to represent relations. An equation is a mathematical sentence stating that two quantities are equal. Relations are often written as equations with two variables, one to represent the domain in values and one to represent the range in values. In the previous video, we made an equation where y equals the constant number times x, and this represented our domain and our range, and it's an equation. You see the equal signs? So again, we're going to learn how to write an equation to represent a situation. For our first key answer, let's draw this little baseball player over here, and let's name her Valeria. Okay, getting ready to hit the softball. There she is, okay, Valeria. Now let's make the real world link. Okay, so let's go down here and read about fireworks that we have right here. Physics can be used to calculate the path of fireworks. In general, for every 1 inch increase in shell diameter, a firework's height increases by about 100 feet. So, for every 1 inch increase in shell diameter, a firework's height increases by about 100 feet. So 1 inch will increase the flight by 100 feet. So right there, we're being told how they relate. Okay, they relate. Every 1 inch of increase is an increase of 100 feet in height. So how does the height of a firework relate to the diameter of its shell? For every inch in shell diameter, the height increases by 100 feet. Some of you may be noticing already that over here the inches can be our domain, our numbers along the bottom. And our height, our increase in height, can be our range, okay, our y-axis. So some of you might have picked up on that already. Number 2. Complete the table to show the approximate height of a firework with different sized shells. Then graph the data as ordered pairs, diameter and height. So here we're going to create a table and then graph it. We've been given the information we know already. 1 inch diameter will give us an additional 100 feet in height. So if this is the unit rate, it will continue with that pattern, okay, to make it a proportional relation. So 2 inches of diameter, which is double from 1, should give us double of 100 feet. And that relationship should continue. Now, it's not going to double each time, boys and girls. It's just going to be added by an additional 100 every time there's 1 extra inch of diameter. So don't make the mistake of going from 200 to 400. No, each one here is worth 100 here. So 100, 200, this should be 300. And there we have it. Now for the graph, we must include our domain and our range. So our x value is diameter, our domain, and our range will be the height in feet. Go ahead, boys and girls, and graph these points on your graph. Okay, so 1 will be 100, 2 will be 200, 3 will be 300, and 4 will be 400. And you'll get a nice straight line that goes through the origin. Number 3. How could you find the approximate height of a firework with any size shell? Well, based on our unit rate, we know that each 1 inch of diameter is 100. So we must simply multiply the diameter in inches times 100. 1 times 100 equals 2. Okay, 1 times 100 equals 100. 2 times 100 equals 200. 3 times 100 equals 300. 4 times 100 equals 500. So we must multiply the diameter of the shell by 100 for any size. So any size that you get, just multiply by 100 and it'll tell you the height. Based on the rule you wrote, okay, so this rule, what is the approximate height of firework with 6-inch shell? Well, we multiply the diameter by 100, and when we multiply 6 times 100, we get 600. Don't forget to include your unit, which is feet. And down here, I'm sorry, I cut it out when I took the picture. It asks for an 8-inch shell, same thing. 8 inches times 100 feet equals 800 feet. Include the units. Okay, now let's look at page 20. Zoom in. A store rents scooters for $12.25 per hour. Some of you can already tell that this $12.25 is going to be our constant. And when they're saying per hour, that's for 1 hour, so that's our unit rate. Okay? You have to think mathematically like this, especially because we're working with ratios. So as soon as you see a number and they're giving you that number, that's going to be the constant, and this per hour is 1 hour, so that's our unit rate. You have to start thinking this way. All right? And that is shown on the table here. Let's, okay? In the graphic organizer, write this relationship using words and an equation. Well, we know that it's $12.25 per hour. You can just write that here with words. Okay, so go ahead and write that down. Right there, the cost to rent a scooter is $12.25 per hour. How can we write that as an equation? Well, let's see. If we were to write this as an equation, I understand that every hour needs to be multiplied by $12.25 every hour, because 2 hours will be $24.50, so it's 2 times the amount of the hour, and then 3 times the amount of the hour will give me $36.75, and 4 hours times $12.25 will give me $49. So clearly I have to multiply the time of hours times the cost times the hourly cost so that I can get that total cost. You can see that, right? So then let C represent the total cost, okay, as you can see here, and H represent the time in hours. So our total cost, so here's the therefore, our total cost will equal $12.25 for the amount of hours. Okay, if I replace, then let's say the hour with the number 4, my total cost will be $49. If I replace it with the 2, my total cost will be $24.50. And there's our equation. Okay, go ahead and write that down. Okay, now let's practice again making a table and graphing it. Okay, with this information. The height, represented by y, okay, the y-axis, or our range, of a hot air balloon increases by 20 feet every minute after it lifts off the ground. The ground will be x. Okay? Use the table, a graph, and an equation to represent this situation. Okay, so now we're going to have the time. Okay, the time, as you see it listed there on the x, okay, in the unit of minutes, 1 minute, 2 minutes, 3 minutes, and every minute it goes up by 20 feet. Correct? Okay, so let's go ahead and represent that time. 1, 2, 3, 4, 5. Okay, and now let's, the height. Remember that our unit rate, we were able to pick it out again, is 20 every minute. Okay, so 20 every minute. So 1 minute, as you see right here, is going to be 20. 2 minutes will be 40. 3 minutes, counting by 20s, will be 60. 4 minutes, counting by 20, will be 80. And 5 minutes, counting by 20, will be 100. And look at that. They've been actually incremented the range by those values. Okay, so there we have it. And are we able to create an equation? Are we able to create an equation? Well, let's see. We have to think of what our constant is. Our constant is clearly 20 feet, right? They told us that it's 20 feet per minute, and it is constant. You see that it's going up every minute. It's going up by 20. So that'll be our constant. Our constant is 20. And when we multiply, we have to multiply it by the minutes, right? We have to multiply it by the minutes, and that's going to give us what? Our total height. But I did it this way just to show you, okay, what this means and what this means. But in order to align it with our graph, we have to replace the variable. We have to replace height with the y, because that's our y domain. As you can see, we're representing it here, okay, the height on the y. And then we have our 20, and the number of minutes is being represented by the x-axis right here. That's our domain. So use this one as our equation. Okay, you can go ahead now and graph it. We know that along the bottom, our domain is the time in minutes, and our range is height in feet. Go ahead and write that down. And you know that in 1 minute you have 20 feet, 2 minutes you have 40 feet, 3 minutes you have 60 feet, and in 4 minutes you have 80 feet, and then finally in 5 minutes you're all the way up at 100 feet off the ground. Graph it, go ahead. And finally, for your sentence summary or your lesson summary right here, remember to always reflect right here. How confident are you about using multiple representations of relations? Well, write that here. We learned about multiple representations of relations. We show our data by using a table, by graphing it, and by writing an equation. Okay, go ahead and write that right there, please. And put a little star on it to show me that you actually did it. And finally, I wanted to share with you the answers to the crossword puzzle that we have on page 21. Let's do a little review. Across, let's do 1, 5, 6, and 8. Statements that are true for any numbers. Properties. The set of all x values in a relation. Domain. A type of expression that contains at least one variable. Algebraic. A variable is a letter. And number 8, the type of reasoning that uses facts, properties, and rules to reach a valid conclusion. Now we're using facts, okay? We're not using opinions. That is called deductive reasoning. Deductive. Okay? And then down. The point at which the number of lines on a coordinate plane intersect, we have the origin. Okay, where we begin, 0, 0. Number 3, a mathematical sentence stating that two quantities are equal, an equation. A letter or symbol used to represent an unknown. Well, we call that a variable. Where is it? There it is, a variable. And number 7, the rules to follow when evaluating an expression are called the blank of operation. Do you remember this? The order of operation, which is PEMDAS. Now, it seems a lot easier when you have the answers there. I understand that crossword puzzles can be hard. Anyways, I hope this helped. See you in class.